to start the year, we're going to talk about metric and SI units. So one of the things we need to know is, are these things big or small? So like a kilometer, is it big or small? Kilometers are huge. We're actually going to walk out a kilometer. A millisecond, is that big or small? Well, that actually is really super fast. So we can't really even time a millisecond. We'll try to do that, but you'll fail miserably. It's okay. It's not your problem. Nanogram, is that a big thing or a small thing? You know, we're used to seeing nanotechnology, so nanos are really small. So we're going to use these ideas, are they big or are they little tiny things, to say, okay, does my answer make sense? So some basic SI units. Okay, most of you know this already, it's okay, but if we're going to measure length or distance, we're going to use the meter. If we're going to measure time, we're going to use seconds. And if we're going to measure mass, we're going to use a kilogram. Now that's going to be a little weird for you because you're kind of used to thinking of grams as the base unit. But you have to remember, we're dealing with physicists here, and for the most part, physicists, they're studying things like trains, cars, planets. So these are big things, so we're going to use a kilogram instead of a gram. And most of our SI units, the other SI units, are based on kilograms. So here's some of our metric prefixes and what they mean. Tera. Tera's really big. You might be seeing right now terabytes in a computer. Terabytes are 10 to the 12 bytes. Giga is 10 to the 9. A gigabyte is a billion bytes. 10 to the 9 is a billion. Mega is 10 to the 6. Are you starting to see a pattern here? You should start to see a pattern here. Kilo, 10 to the 3rd. Centi doesn't match the pattern though. Sorry guys. Centi's 10 to the minus 2. Centi, cent, like 100. So there are 100 centimeters in a meter, or 1 centimeter is 10 to the minus 2 meters. Milli, 10 to the minus 3, and the rest of them follow the pattern. Micro, 10 to the minus 6. Nano, 10 to the minus 9. And pico, 10 to the minus 12. So we're going from 10 to the positive 12 down to 10 to the negative 12. Pico we're not going to use very often. We'll use it like in one instance. Nano we'll use a little bit more often. Tera we're going to use with power. But the ones that we probably will use the most are kilo, centi, milli, and micro. We'll use nano. We might use mega or giga, but these 4 here are going to be our main metric prefixes. So these ones here you should know like that. You know, those should be fairly easy. Alright, so one of the things we're going to talk about is standardizing units. Okay, so any distance given in centimeters has to be converted to meters. Okay, if you are given a distance in centimeters or kilometers, you have to convert that to meters. Any mass given in grams or milligrams must be converted to kilograms. And any times have to be converted to seconds. So let's do one of these. Let's give a distance in kilometers. Okay, so here's our distance. Let's say we're given 12.5 kilometers. Okay, so we need to convert that to meters. Okay, the T-bar, the across bar means to divide, and the up-down bars mean to multiply. So if you haven't seen this form of dimensional analysis, it's basically this form of dimensional analysis times, okay, with it kind of compacted a little bit more. It's just kind of a little bit more organized. So we know that 1 kilometer, okay, so the 1 is always going to go with the number with the prefix. 1 kilometer is 10 to the third, because kilo means 10 to the third, 10 to the third meters, so that's going to give us 12,500 meters. So that was easy enough, right? We don't have to worry about that too much. Alright, so let's try to do a mass given in grams or milligrams. Let's do milligrams just so we have a two-step conversion. Let's say we have 250 milligrams. Okay. Okay, we don't know how many milligrams are in a kilogram off the top of our head. Some of us do, but most of us don't. So, but we do know that 1 milligram, okay, they have to be diagonal from each other like this in order for them to cancel. 1 milligram, what does milli mean? Refer to your notes. What does it say? 10 to the minus 3. Milli means 10 to the minus 3 grams. So our milligrams have canceled. And then we need to get to kilograms. So we know that 1 kilogram is 10 to the third grams, because kilo means 10 to the third. So what we're doing is we're just taking the prefix and replacing it with its meaning. We're taking the prefix and replacing it with its meaning. Notice the 1 is going with the one with the prefix. So this comes out to, this is going to be a really small number. This is 0.123425. No, I think I have one too many. Yep, I have one too many zeros. One too many zeros. I did it in my head. That's what happens when you do things in your head. Okay, so it's basically 2.5 times 10 to the minus 4 kilograms. Good? All right, so let's take that one and put it away. And let's do a time given in minutes. This is going to be the one of the ones that's going to trip us up a lot during our time, because we're just going to go, oh, I've got this time, but it's going to be, oh, I'm supposed to convert it to seconds. So let's say we have something running for 2.4 hours. Okay, we have to convert that to seconds. Well, most of us don't know how many seconds are in an hour. Okay, most of us don't know how many seconds are in an hour off the top of our head. So, we do know that 1 hour is 60 minutes, and that 1 minute is 60 seconds. See how when they're diagonal from each other, we'll cancel those, so the hours cancel. And the minutes are diagonal from each other, so the minutes will cancel. And we're left with seconds like we want, so we're going to go 2.4 times 60 times 60. And that's going to give us 8,640 seconds. Okay? Now, what should you write down? Here's kind of one little conversion factor that's going to make our life a little bit easier. You should know that 1 hour, you don't have to know it because you could go through this. 1 hour, though, is 3,600 seconds. Now, a lot of kids get messed up and they say 360, so make sure you know it's 3,600 seconds. So you should know that. You should also write down these metric prefix, the meanings of these metric prefixes. We're going from 10 to the positive 12 to 10 to the negative 12. One thing you might want to do is make a stupid mnemonic with these prefixes, T, G, M, K, C, like, I don't know, make one up. We'll have a contest who can make up the best mnemonic for remembering these guys. But you don't really have to do it because you have your handy dandy equation sheet and you can write them down on it. Or if you're using the AP equation sheet, they're on it. And then you should know your basic SI units. Those are the ones that we're going to standardize our units to. And so that's it. I hope that was easy enough. It should have been. Thank you. We'll see you tomorrow. Bye-bye.